Hi, good morning, all. Welcome to the lecture series of Java Advanced. Basically, we'll cover the Java Advanced topics here. Uh, Before we move on, we'll just discuss the schedule of the series, how it's gonna be, and I'm ready to take any questions before the start. Okay, so the classes are going to be every weekend, like Saturday and Sunday. Mostly it will be of 3 hours plus additional 1.5 hours of tutorial. This will be on the weekend. On weekdays, I have chosen Tuesday and Thursday. It will be of 1.5 hours lecture in the evening. Proposed plan is 7 p.m. The proposed plan for this is 9 a.m. I hope everybody is fine with the schedule. Any questions? I'm happy to take. Other participants, can you please also confirm? I've got confirmation from Manjunath.
Abhishek?
Yes.
Yeah, so can we change the weekday timing? Because I reach home around 7:30, 7:15 to 7:20.
So you want to be pushed it later or pushed it before?
Pushed it later.
Okay. How about if I make it 30-minute more, 7:30?
Yeah, 7:30, 7:45, it is okay.
I would keep it up to 7:30. That will be good for others as well. Fine.
Okay, okay.
Thank you. So we'll stick to this particular schedule. Okay. Now, agenda for today. So this is going to be a kickstart meeting for the entire course. So what I'll do is I'll give you an overview of. I'll get started from the basics just to kind of give overall summary, and then next thing we'll also take a look at some of the questions. They are very good questions, and if you just that will help us brush up the concepts. Okay. And this is again just for today. And by today itself, we'll get started into the Java architecture and so on. Okay, fair enough. So let's get started. So this is going to be your module 0, not module 1. So we are starting just like an arrays, and the index starts from 0. Okay, moving on, right? So what exactly is Java? So you all are working professionals, so you must be already familiar with what exactly the Java is. The good part is Java is quite old, like 30 years plus old programming language. And it's also a pure object-oriented programming language. And what exactly object-oriented means, we'll just take a brief on this. The only feature that it has is write once and run anywhere. So that's the very good feature of Java. Currently, it powers at least this data is still slightly old. It powers close to 5 billion devices, and 5 billion devices are not just computers or servers. They are also different type of devices. We'll take a look at that. So keep in mind that Java was developed 30 years back, and it's continuously evolving and still relevant today. So there are a lot of languages which came after Java and still and they got outdated long back. But Java is something that remained relevant and still continuing to be one of the best programming language. Moving on, what are the development environment people use? So there are two aspects of it. One is called JDK, which is nothing but the Java Development Kit, and another is called JRE. Now, one question I'll put. Imagine I give you a program and you are given a blank computer. What additional I'm giving you a Java program. Let's say hello world of Java program is given, and a blank computer, right? Blank computer is given to you. Okay. Blank computer as in like it just has some operating system. So what else we need to run the program? You can type your options in the chat. I'll take a pause here. Okay. So I'm giving you a, let's say, hello world dot Java. That's the program that I gave you. Okay. So pretty much I'm getting the answer right. So first of all, we need to understand. So participants, can you please mute? I'll ask you to unmute if needed. Otherwise, the class may get disturbed. Thank you. So the Hello World program. So first thing Java needs is the compilation of the code. And in order to compile any Java program, what exactly we need is the Java compiler. And Java compiler comes packaged with something called a JDK. This is Java Development Kit. Fair enough. So what we need, we'll need JDK just to compile. But imagine somebody told you that you are given a jar file, or let's say the dot class file. So whenever we compile, let's say we compile using Java C command, and once I write Java C and then hello world dot Java, your output is gonna be hello world dot class plus, right? Plus any other dot class file, right? Right? For which the class definition is present within this particular file. Okay. So whenever we compile a program, what we are going to get is dot class file, and this contains the bytecode. Class files are nothing but it will contain the bytecode. We'll go through in detail on what exactly happens in the bytecode, how it gets executed, all right, inside JVM. So we'll go through in detail of all of it. I'm just giving you a glimpse just to get distinguished between JDK and JRE. So what we need is if I'm given a pure pure Java file, I'm gonna need the JDK to compile. I cannot completely compile using JRE. Okay, so JRE is just used for Java runtime environment. And what comprised of JRE, again, we'll come to that. Also, we do use any of the popular Java IDEs, and we should use actually IDE only while creating the projects. Whenever you are trying to learn any of the programming language, the best way to learn is go and type in your editor, and that's how you will be asked during your interviews. You will be asked to write. Yes, any ID is fine, Abhinay. So any ID is fine, not just these IDs, right? These are most popular one. There are now much more popular. For example, Cursor, Windsurf. You can use Replit and so on. Okay, we'll come to these aspects of it, but the at the beginning, I'm giving you a recommendation whenever you are trying to write any piece of code, even I would say you try to use Java, Spring Framework, and so on, you you should be capable of writing without IDE as well. I'm saying you should be capable of. You need not be doing it right on a daily basis, but you should be capable of writing your program without help of any IDE, without any auto completion. In that way, you will know exactly which functionality is coming from which particular library. Okay, which class, which method is this functionality implemented in. Okay, so that's the one of the basic recommendation. So in order to run any compiled Java program, we need JRE installed on the particular machine. Now, from where we do download and install it. So Java was initially developed by Sun, but now it's acquired by Oracle, and Oracle provides a particular a downloadable website from where we can download the Oracle JDK. Now there are different flavors of JDK. Okay, so because Oracle made Java proprietary, so beyond JDK 8, you may not find the Java open source by Oracle. So there is a different community that came up that is called OpenJDK, and so OpenJDK Java, and there are other flavors of Java as well, right? So what we are gonna do throughout the course, we are gonna work with OpenJDK 11. You can take a note. OpenJDK 11, and then once we deep dive, or whenever we want to or while we want to start using the latest version of JDK, just to learn what are the features that were added, so then we'll upgrade our JDK version. But unless specifically mentioned, we should be compatible with JDK 11. Any questions so far? You can give some reactions of if you don't have any questions. Cool. Thank you. Now, the basic program structure, why when we call Java as a object oriented, which one currently running most production system, which version, right? So, okay. So production system, when we come to Java, so they get production system needs to be up to date with the latest version. The reason what I'm saying, or most stable version, I would say, okay, not this latest, stable version. Okay. So JDK also has come up with a two type of, just like Ubuntu. Okay. Just like Ubuntu, there are two type of release. One is LTS. This is called long-term support. Another is the another some minor release that happens on top of specific LTS. Okay, and this long-term support is given a duration, like this version will be supported up to, let's say, 4 to 4 years. Okay, so after 4 years, there will be a new LTS created, and you have to migrate to this. But up to here, let's say 2022, you got a new version of Ubuntu, or same goes for JDK, and you have a support for 4 years from the community. So what you will have is, up to 2026, you will continue to receive the updates from the software provider, because it's a long-term support. And then you will okay, so what updates that will get? So mostly involves the bug fixes or the 0-day vulnerability fixes. So any security things are found, they will get addressed as part of the next minor release, and you need to keep applying those patches to your software. So production, I have seen in the cloud, you need to keep patching your softwares that you are providing software as a service. Basically, every month we used to patch the entire operating system plus the Java. That's how it should be in a cloud environment, because cloud are meant, I mean, it's exposed over the network, and it's meant to be, I mean, you need to keep it secured. Otherwise, you will go for a toss. Hackers will do one breach, and you will get all the licenses canceled from other organizations. Okay. Moving on. So Java program structure. So any Java program that you write, it must be defined within a particular class. That's the very basic requirement of a Java program. Unlike other languages, for example, if you have a written C or learned C or C++, we don't necessarily need to type it within a class. Even Scala is also written on top of Java, but Scala also can be right. Those they are mostly how you used to do. Can just give me some glimpse during the upcoming session. Okay, the how the patching used to be done. Yes, will definitely let you know. Okay, so. Okay, so okay, got it. So what we were looking for is in Scala, you can write methods outside of your class as well. So Scala is mostly the functional programming language, and Java is object-oriented programming language. You might get asked why Java is object-oriented programming language, or maybe what are the features of object-oriented programming language. It's a very basic question you may get asked in your in your early years of your interview. For example, when you are up to 3 to 5, you may get asked sometime. So again, the must have part is the class definition, and then this is optional. If you are creating a library, you don't need to write a main method within that particular class. But if you are writing any application, an application must have a entry point, and that entry point is decided by the main method that is present uh, within the class. Now, how do we specify? Okay, so okay, let's say let me take an example. uh, let me take an example. Sorry, done. Here Java program structure. So let's say I'm just writing a hello world, okay, example. Hello world. I'm just writing here public static void main, then string args, okay, and then sorry. So okay, let's say I have a curly braces here. Now I'm just writing a sysout system dot out dot println hello world. Okay. Now let's say this is present in a class file called hello world dot java. Okay. Now, what are the command to compile? Java C hello world dot java. This is the very first command that you will write on your terminal so that you will get the compiled class file. Condition is that if there is no compilation error, okay, if there is no compilation error. If there are any compilation error, the error will be displayed on your prompt and you need to go and fix it. Now, the next command you will have is Java and the class name which contains the main function. Keep this in mind. Which class will provide Java space here the class name is hello world and you need to enter. That's it. And that's how this program will run. Most of the time, we don't realize exactly which command, how to choose this class name, which class name it will be. Imagine, okay, now the very next question I'm having, can I put this class in some different file, abc.java, and will this program compile? Answer, yes. So, okay. So this program will compile. Reason is I haven't stated this class, hello world class as a public. Imagine I wrote this public class hello world. Now, if I put this piece of code in this particular file, will this compile? The answer is no. Okay, fair enough. Be with me so far. So the point is, imagine you have written a big application and you have written main method in different classes or several classes you have mentioned. Now, in order to run that particular class main method, you need to invoke something like this. Now, whenever you use ID, you create a runtime where you provide these arguments. Okay, so you provide the Java path, and then you provide the class name which you are going to run. Now, IDE also provides you an option of a play button. You can just, or run icon, you can just click on that and it runs. Okay. So, I mean, if you are very addicted to IDE, you might not get to understand these details. Fair enough. Now, moving on. These are the very basic data types. So I'm not going to go into the detail of it, but keep in mind what exactly this means. Okay. What exactly this means, why they are of different sizes and how they work internally. So you may get asked these questions whenever you are writing Java program let's say for embedded devices. You might be asked to understand the detail of it. So it's nothing but these provides this 16-bit, right? They provide the ranges for your particular variables. So any variable declared of type sort, they will range from -2 to the power 16 to 2 to the power 16 minus 1. Okay, so that's how these ranges gets defined. Same goes for the different type of this, and same goes for example, char as well as the uh, boolean. There are other types in Java like string, arrays, and objects. Okay, and they also, right, so objects, how they get stored, I will come to that. But yeah, these are the basic data type that we have inside Java. And point to note, not to remember these values. These values we don't need to remember, at least in I mean from interview perspective. But what you need to remember is the significance of these, right? What if a particular variable is of 16-bit? Now, if you if you start working with let's say, for example, I'm just taking an example, AI here. AI have, right? In AI, what we do is we do a lot of matrix multiplication. Okay. Now matrix multiplication, and imagine you have declared a data type of let's say double. Okay, double for each element of the matrix. Let's say it's a 2D matrix, and you have declared the data type as double. So what it means is that each multiplication operation or addition operation will involve 64-bit operation. Okay, and that's how the expensiveness of the program is calculated, or the memory, how much memory that it will take, that gets computed. So what the general practice is, they downsize it, basically make it 32-bit, and then they run it. So it will be at least it will be 50% as efficient as it would have been with double variable. So we need to keep these minds of why these bits are present and what's the notion of it. Any questions with this? Up to here, if you have any questions, please do ask. Okay, we'll move on. I see there are no questions. These are the basic operators and expressions. I'm not gonna go in detail. Basic thing that to keep in mind with these are the precedence rules. In some of the complex expressions, you need to look for the precedence rules plus the associativity of these, like whether it is left associated or it is right associated. Okay, or right association. Okay, so basically, these are the operators and expressions for that gets used with Java. Same, moving on, control flow, conditionals, and the loop. So these are the conditionals, if else, switch case, and then ternary operator.
Sir, actually, so I believe for the Java 17,
Mhm.
so we have certain like I think switch case is changed, right?
Yes,
As
we'll come to that.
sure,
So as I mentioned already, that right now whatever I'm focusing on is mostly reliant on JDK 11. New features of Java will be covered one by one. Okay.
sure, sir, sure,
Just
yeah,
to not get confused with what is right since beginning or what's new that has come. Okay. So we'll cover
sure,
that
sir.
separately. That's why
Okay,
I'm just giving you a very brief. It's a I'm just recapping it, okay, so that you will have a quick glimpse on okay exactly what all things are there. Now, if else and switch case and the ternary. Now, only caveat comes in case of switch, okay, and the caveat is if you don't provide a break statement, okay, and you have several cases, okay, case one, case two, right? And case 3 and so on, and the last gets as default. Okay, so imagine you have several of them and you forgot to provide the break. What happens is wherever whichever case it matched, let's say the first match happened at this, so all the subsequent case statements gets executed after it. That's the only key point that we need to remember with switch. So whenever we see a program of that particular involving switch case, this is the only thing that will come to my mind. Okay, that I need to be very careful only in this particular scenario. Okay, moving on, for loops, while loops, do while, I don't need to describe. These are very basic, and this gets evaluated. The only caveat I would say is the always focused on the number of semicolons that you see. Okay, sometimes you might see let's say two semicolons and then just one right, the third one which just does the increment operator, right? So what it means is this is equivalent to infinite loop unless you are given any break. Okay, even if you have given a break, right, this is still corresponds to infinite loop in case of for. Okay, while and do while is still good. Do while, the only thing is first the block execution happens, then the condition gets checked. So that's the thing. Next, control statements, break, continue, and the return. So break can be used with while, do while, or I mean any iteration or loop statements plus switch case. So only these are the two places we can use break. Continue also gets used with with loop statement. Anywhere else continue gets used? Anybody? Okay, it's a very old thing. Like in case of macro, also continue gets used. Okay, but it's very rare. You might not find any program with this. Okay, now return. Return. Okay, so one thing, right? The break statement. Let's say you are having a nested loop for and then nested for. I have written break over here. So break only exits from the innermost loop, the loop where it is present. That's it. It doesn't do anything for the outer one. It doesn't do. It doesn't even know what else is right outside of this particular block. Okay. So that's the key thing that we need to keep in mind. Like break, any simple program that you find with break, you just need to ensure that you're just coming out of the inner loop. If I have to come out from the outer loop also, right after this, I have to put somewhere break, then only I'll be able to come out from the outer loop. Okay. Next, continue again. Continue, what it does is continue shifts your control from, let's say, at a particular line in a loop. In a loop, it gets used. Let's say somewhere it is written continue, some statement if, and then continue is written. So whenever continue is written, the next statement that gets executed is the for the second semicolon thing. So first then this will start getting executed, and then the third one. Okay, so that's how the execution happens with respect to continue. Okay, these are very, very small things. I'm not sure, right? We just to refresh all this. Moving on to return statement. Return statement gets used within a method, and within a method you can use the return statements, as many return statements that as you want, but in a particular flow you should have exactly one return statement, and after return statement there shouldn't be any further statement. That's the very, very right. So in a particular branch flow, if you have a return statement, any statement that is put after will not get executed. In your normal flow method definition, if you just wrote the return and then after that you are writing, so that those statements will not get executed. In fact, you should get the compilation error in that case. Okay. Now, moving on. So we'll have introduction to methods. So method, right, what we do is we call it something called method declaration. And then whenever we write, in order to invoke this particular method, I need to do the parameter passing, and then methods basically it accepts the parameter, it returns the values. That's it. And then invocation happens like just like we call it. Okay. So these are very basic things, right? Declaration has just access modifier is anyway there. Then there are return type, name, and the parameters. Parameters anyway, these are the input part. Okay, so these are input and this is the output. Input to the method and output from the method. Okay, output from method. And the method invocation, right? And we can use it like object references to invoke it, or we can directly call static methods. Okay. I hope there shouldn't be any questions up to now. Okay. Again, coming to the classes. So classes define the structure and the behavior of the object. So we should be very careful with these terms. So these are right, blueprint which defines the structure and the behavior. Well, structure are nothing but the member variables, and behaviors are nothing but the functions that you write within the class. Okay. And object instances are nothing but the particular state. It represents a particular state of the blueprint that is declared before. So in Java we cannot create an object without declaring a class. So objects are always instantiated from the class. Okay. But I'm just giving you an example. You might be wondering, in Scala, you can directly write object like this. So you can directly create object. Okay. So that's why I'm just referring. So in Java, you will always need the class definition to create the objects. But there are programming language where you might create the object without classes also. Okay. And the constructor. So constructor are nothing but it's a special method which doesn't have the return type. That's it. And it is used, right, to create the new object of a particular class. Now, very basic question. Constructor is invoked after the object is created or before the object is created?
Before the object is created.
Okay. And the answer is correct. So sometimes, right, there are confusion, like some of the folks understand like uh, object is created then constructor is called.
Yeah, actually, when we use that new keyword, that time only that memory get allocated for the,
Object
yeah,
for the object.
for the
But
object, yeah.
correct, so memory allocation will happen, but the actual constructor invocation will happen after it. Okay.
Uh,
Okay.
okay, sir. Can you please come again?
Okay. So I would say whenever a new, let's say I have
So So as soon as the class loader get invoked
Uh-huh.
into the JVM,
Okay.
that time only that constructor will get called, right?
Uh, okay. We'll bring in class loader once we reach class loader. Okay.
Sure, sir. Sure. Yeah.
Okay. Okay. So we'll once we reach class loader, definitely we'll bring in the class loader into the picture. Okay. But for now, what you can assume is if your constructor is once the constructor invocation completes, that time you can say your object is created completely. That's it. Okay. Okay. For now, understand this. If your constructor invocation gets complete, so even if we all know, right? So the constructor, the very first line of the constructor gets written something like this. Agree? Agree? Are you familiar with this line? Yes? No? Okay. Okay.
That is the this constructor, right?
No. We'll come to that. This is a keyword. It's not a constructor. Okay. Keep
Okay. Okay. It will
always.
represent the current class object.
Yeah.
Current class
So what
object.
it represents is different. I mean, is different thing. First of all, we should be very careful with what exactly we mention. So this is a keyword. Okay.
Sure, sir.
Okay. It's not a constructor any. Similarly, you will have something called super, right? Super is used to invoke the base class constructor. Fair enough. This is used to invoke the current class constructor. Fair enough. Okay.
Yeah. Yes, sir.
Now, now this I have written with the parenthesis. This is also written without parenthesis. This dot we can refer. Okay.
Yeah. When you are giving that parenthesis means that is the instance block.
Yes, that's correct. It's an instance block. Fair enough. Uh, Others can also right ask your questions. I see right only Vinay is asking questions. So we'll move on. We'll again come to the details of it. But
But again, that if we use the static block, then that will execute first, right?
yes.
Means
So
forcefully we can also execute.
okay. So static block. I'll come to that. So static block or any method, or sorry, not method. Yeah, any method you declared as a statics. For example, public static. Let's say void. Let's say I'm just writing. Yeah, sing. This is another static method, and this static can also be used with variable. For example, private, or let's say not private. I'll just use public. Public static, and then int, right? Solves. Let's say. Okay. Now. Static, these are the main uses of static keyword in Java. Either you can associate it with any attributes, or you can associate with a function, or you can just write a plain static block. Any of these members or functions can be invoked without instantiation. Without instantiation of the class. Fair enough. Now, what it means is that how, how will okay, we'll come to that. How will JVM know when to invoke these static blocks, right? So we'll come to those questions once we talk about JVM, how it works, internal working. I'll definitely explain everything. But remember one thing, static can be used in these three scenarios, and any of these attributes or the functions declared with static can be invoked without instantiating a particular class where right these members reside. One more thing to note, because I'm discussing here, within a static you can't access non-static members. Okay. Within a static, you can't access non-static members from the static block. Okay. Anybody has any questions? Feel free to ask Hers or Manjunath.
No, Vishal.
Okay,
Yeah.
thank you. Cool. So next, we'll move on to object-oriented programming principles. Now, any language that is object, right, that follows OOP paradigm, they will have these four. These are the four pillars of any object-oriented paradigm. So they will follow these four rules. Okay. So what exactly it is, right? So abstraction. So Java in Java, abstraction is achieved via interfaces and abstract classes. How does Java know the class is abstract? Because the declaration of the class happens with the abstract keyword. So just like this, I've just given an example. So abstract class vehicle and and basically again right, this is the concrete class which is extending the abstract class. Now, very specific requirement: abstract class must have at least one abstract method. Any question? Does this statement always hold true? Does this statement always hold true? Yes.
Yes.
Yes. Cool. Thank you. And again, right? Though how we can represent the same with the interfaces. So interfaces also, we just declare those methods. Now, in the new version of Java, right, there are something called default methods. And with these default methods, what we can have is the default implementation of the,
Oh, that too also only public defaults, right?
yes, yes, of the default implementation of the method. You are right. I'll mention. Now, why this was introduced, and after introduction of this behavior, how it's relevant to the abstract class? That's the very key question. And why this was introduced? Okay, so any new feature that gets introduced in any version of Java, you can refer their documentation. They are called JEP. They are part of some JEP. JEP is nothing but it's called Java Enhancement Proposals. Proposals. Nobody asks you like as part of which JP this came, but this JP gives you a kind of ticket number. You can track like, okay, these are the changes that came as together, and let's say new enhancements that comes after this. So they will link the older JP with the new one, or let's say they are going to deprecate something, so they will also use the older JP number to refer this. So
So, so are those are made public to the?
yes, yes,
Okay.
yes, 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 yes.
Okay.
I'll give you the websites to OpenJDK website you can open. Okay. And you can look for the Java enhancement proposals for a specific JDK version. Okay. So
Okay. Yeah.
you can look for that. Okay. So what I was mentioning is what's the rationale behind introducing this this default methods. Now imagine one thing.
For backward compatibility.
Yes, so imagine you have a interface that was already introduced in a previous version of Java. Now, let's say in this interface, tomorrow we realize that a particular method is needed. Okay, a particular method. For example, SAPE might not be suitable a new method, but for example, right, let's say some XYZ is a new method that is needed for this particular interface. Now, by convention, we could not do that. We could not change any of the existing interface of the Java class, Java interfaces, okay? And any of the existing interfaces we could not change. But with the introduction of public default methods, we could change the existing implementation. Now again, why we could not change? Because it will introduce a breaking changes. In software, any changes that you introduce, it should not be it should not break the older behaviors. For example, let's say you introduced xyz method. Let's say it returns some int. And now what you did is you just rolled out the updated version of Java, and there are some implementations of this particular interface that like we are seeing in rectangle class. Now they will, as soon as I upgrade to the new version of Java, this program will start giving me the compilation error. Okay. And that's why we could not introduce the breaking change within the interface. Like we could not add any new methods. Otherwise, all its implementations, not just right. Imagine you can say that okay, this was part of library, and I'm just the one who is implementing it. So I can just change all my implementations, and I'm good, and I can roll out the change. No, that's not acceptable in the software industry. Software industry, right? So interfaces were brought in to define a guideline. So anytime you want to depict the guideline for a particular for anything, okay, you usually go and declare it as interface, so that anybody who will implement that particular interface will implement those methods, right? So basically they will follow your guideline, and anybody who is gonna call it, they know how to call, right, if something is of shape type. If something is of shape type, I have a method which is draw. I can call a draw method on the object's instance, which is of shape type. That's what the guideline means. So understand this very, very carefully. So any method in the interfaces world, these were called as guidelines. Now, why abstract classes were added? So imagine you want to keep certain functionality closed. Like you don't want somebody to modify certain features, but you do want them to implement some other features based on their needs. For example, how the vehicle will start may depend on, right, what type of vehicle it is. If it is a bike, it's gonna start by, right, by a kick or click, or a button, push button. If it is a car, you can have an option where you can implement the start method by pushing or a button on your phone. Okay, so it could be that. So why abstract classes came? Because we wanted to fix certain functionalities. Right now, they have written a fuel method, right? So fuel also can be made as abstract, because if you want somebody to run on hybrid fuel or some other type of fuel, right? So they can do that. But in this example, let's say we have restricted the fuel part. So abstract class need was, if you want to restrict certain features, but you want flexibility, you want to provide flexibility on some other aspects of it. And that's why the abstract classes were introduced. Okay, so I believe things are now clear why default methods were introduced, because with the introduction of this, now existing interfaces can also be right be allowed to have new methods, new guidelines. You can add a new guideline to the existing interfaces, but the caveat is you can provide the default implementation of it. So if somebody is not following your guideline or not implemented your new guideline, their code still runs with their default behavior. Okay, any questions you have related to these? Any of you? I'm open for discussing.
So now like after 1.8 onwards, we are not achieving 100% abstraction, right?
No, why can't? Abstraction can still be achieved. So imagine I just wrote abstract class, and I'm not having any method with the concrete implementation. That's still
Or
fine.
okay, means with the help of the abstract class we are achieving that.
Correct. I mean,
Uh,
with the help of this also you can achieve. I don't put the default method. I'm able to. I'm giving you the 100% abstraction.
okay, with the help of interfaces.
Yes, both, right? These two
Okay,
continue to hold with even after introduction of JDK 1.8.
okay,
It's
yeah,
not
sure, sir.
mandatory, right? It's not mandatory to have the default methods always with your interface. No,
Hmm.
nobody asks you to do that. Okay?
Okay, so just what about we have that a default static methods also, right?
Yes. Yes, we'll come to that. I'm just covering.
So is the means that public default that methods are by default also static, right? Or we need to make them static purposefully to use lambda expression, or
Wait.
I think to use lambda expression we need
What
to
what
use.
exactly what exactly your question is?
No,
So
yeah, my question was like in the methods of the interface of the latest version after 1.8,
uh-huh.
uh, uh, do we need the means
Do
is
we
that
need to mandatory?
compulsory?
Uh-huh.
Yeah, that static method, because see, variables are by default final static only in the
Correct.
interface,
Correct.
but
That's
in the methods are that only.
uh
Methods is also,
okay.
I think,
Methods, I
static.
think they are also default. If you are using the default methods, giving the default methods, I think they are default static. That's what I feel. Okay, but I'll get back to
Okay.
you on this. I'm not
Sure,
very
sir.
clear on this. Okay.
Sure, sir.
I'll get back to you. I'll take that as a question. And so if methods are static, if default methods are static by default. Okay. I'll get back to you.
So means so when we are doing the concrete implementation, right?
Uh-huh.
That time we will be considering this, right? But when we have the abstract methods in the interface,
Mm-hmm.
so those are also static by
No,
default.
no.
Those
Abstract.
are public, right?
Yes. No, so those are okay. I'll just clarify you. Okay.
Because interface we have a two type of methods, right?
Yeah, I'll clarify you.
Sorry.
So default the methods which you kept abstract in the interface are as is. For example, if you do not specify any of the specifiers, right, either public, private, or protected. So this is default one, and default is like package, right? Okay, they are never static for sure. These methods are never statics. Okay. Okay, cool. We'll move on, and again we'll come back to this when we discuss AD 1.8 features that were added. Okay, so we'll come to that.
Sure, sir. Yeah.
Next, interface. Again, the only motive behind adding interface is like allow a class to acquire properties and behaviors from the parent class. That's it. That's the entire motive of the inheritance. And in Java, this is achieved by extends keyword to create an inheritance relationship. Same, so class to class is also extends inheritance, interface to interface is also inheritance. Okay. So inheritance, whenever comes, the only thing that will come to our mind is extends, and it happens to same kind of the same type of the entities between class to class and between interface to interface. Okay, moving on. I think, oh, this was duplicated. Okay, fair enough. So I'm just giving a very brief example. We have got an animal class. Yeah, We have got an animal class, dog extends animal, and it has just implemented the new method, right? That is bark. Now, here, if you see dog, right? Using this reference variable dog D, right? Okay, just to be very, very clear, I'll just elaborate here. So new is again, new is an operator. Okay. You can also call it as keyword, but new is an operator. So what new gives? So wherever new is written, okay, a new, what it does is it creates objects. Now objects are created in the heap. Okay, keep these terms in mind. I'll again introduce, come back, dig deep. But for now, right, objects are created within a heap. Now, whenever I write dog D, what is D? What is the type of D? Can
That
anybody?
that's the reference.
Correct. This is a reference variable. Always mention or call it as a reference variable. It stores, I'm just writing, stores address of an object of type dog. I'm saying not the address of right dog object. No, I'm not saying. I'm saying I'm giving a type or type dog, because if let's say tomorrow somebody else also class XYZ extends dog, okay, this happen, still dog D1 will be able to hold the address of XYZ. That's because XYZ is a type of dog. Okay, XYZ is a dog. Okay, so dog D is a reference variable and it stores address of an object of type this guy. Okay, so similarly, if I tell you, so object is also a class in Java, yes or no? This is also a class in Java. Okay, and this is the supermost class in Java. Supermost as in this is the base class of all the classes. Java. What it means is that object variable, object, one can store new of anything that you give. Okay, new of anything that you give, it can store the address of that. Any questions anybody has, feel free to ask. Okay, remember always object is the supermost class in Java. This object, it will be written as O uppercase. Okay, naming convention you must be knowing, right? So any class name always starts with a uppercase. Method name starts with a camel case. Camel case as in something like this: CAMEL and then CASC. Okay. So be very thorough with the conventions whenever you are writing examples in your interview or anywhere. You need to use right set of words, right set of terms. Plus, you need to use these standards, basically naming conventions, class conventions, method names, return types, and so on. Okay. So I said dog is a right, so it's a reference variable and so on. Any things are clear? Anybody thinks that this program will give compilation error? Yes, no? I need answers, please. Anyone? Shivam, you have been silent.
No, it's not giving any error.
What's the reason? Okay, I'll think you. I'll let you think from the compiler perspective. Compiler will see that this is the very first line. Dog is a class. It already knows this is a reference variable. It created the instance of it. Fine. But now d dot eat method. Now dog class does not have eat method. What will compiler do?
So, when we extend the parent class, the animal class, when we extend the animal class, So automatically the properties of the parent class is inherited by the child class already. So when
Okay.
we create an object of the child class, so we can easily, so they can easily reach the properties of the parent class as well.
Yes, because of the inheritance property, right? Because dog
Right.
extended animal, so it will inherit the behavior of the animal also in this particular case, which means it will also show you the behavior of eating. So whenever, right, the compilation just like right, I'm just trying to show you step by step. You need to do it right while solving a real problem. I'll come to that. Okay, so whenever a compiler sees that D is an instance of dog, D, right, refers to an instance of dog. So it will see whether dog has it method or not. It doesn't, then it will go to its base class. It will see animal has it method or not. It will find that, okay, animal has it, and that's why this line will get compiled. Okay, same D. D has a refers to an instance of dog, right? Now
Right.
it 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 will look for the bark method, it finds here, and then this line will also get compiled. Okay. Okay,
Okay.
fair enough. Now moving on, so there are different type of inheritance. There are basically uh, you can say single, and then multi-level, or hierarchical. Okay. Single as in a class extends just one level, right? The extension happens only at the one level. That's why it's called as single. Multi-level as an animal, right? So mammal, so it's like animal, mammal, and then dog. Okay. Mammal is an animal, dog is a mammal, dog is an animal also. Okay. So it we need to read it like this. Okay. So animal, so basically this is the parent, child, and so on. So this is the multi-level. So mammal extended animal and dog extended mammal. Same, this program will again get compiled because of the inheritance. Coming back to hierarchical again. So you have something like animal, okay? Then you have dog, then you have cat, okay? And so on. You can have another set of hierarchy also, okay? Now, what type of inheritance not supported in Java? Same, multiple inheritance are not supported. So you can't have something like dog extends mammal, comma, animal. You can't have something like this, okay? Same hybrid you can't have, like just like you can't have this guy together. So that's why you will not be able to achieve the hybrid, okay? So same, these are things that we need to always keep in mind, okay? Now, we should understand something called as EJ versus HAJ. So any extension, okay, so I think EJ I briefly discussed. Dog extends mammal. And why I'm saying is a and has a emphasizing on this. Whenever you work on a project, you will understand. So whether, right, so we'll come to that. Okay, so you will understand the importance of EJ versus has it. Okay, now class. Okay, let's say class dog extend mammal. So what we can say is dog is a mammal. It's the other way, right? So whoever extends, so that is a type of this. Simple. Okay, so dog extends mammal. Same has a if it contains. Okay, so car has wheels, car has engine. Okay, this is called, this is example of has a, this is the example of is a. Now, whenever you will be asked to design a class, you will fall in this dilemma whether I should go and extend or I should go and do the containership relationship. Okay, while working on a big project, right, working with a lot of classes, you will definitely get to this. Okay, so always keep things in mind. Unless I want to unless I want to be a type of the class that is there. Okay. Unless a dog wants to be a mammal, dog need not extend mammal. Also, unless I don't want to inherit, okay, unless I want to inherit any of the behaviors of the parent class or any other class, if I don't want to inherit, then I don't need to establish this relationship. Okay, so be very, very clear about when to do, right, extend, when to do container shape. This is very, very clear. Okay, so
Sir, can you come again? So means has a relationship you are referring as a container ship.
yes.
Something you told na container ship. So what is that?
Sorry. Don't kind of misunderstand with the containerization and so on. Okay, I'm
No.
okay. I'm just saying, if a car contains wheels and car contains engine, and that's why I'm saying car has wheels and car has engine, because I have declared member variables within the class, and that's why I'm calling it a has a relationship. Okay.
Okay. So just one curious to know one thing. So which is more memory consumable operation, easy or has it?
Okay. You answer me. Which is more consumable operation, memory consumable operation?
I I think easy.
Is it? Why is
Yeah.
that? Why do you think so?
Because when we do that easy, automatically it will create the object for the super class also. Means extend we do no.
Okay. We'll come to that. We'll come to that. That's the interesting concept. Okay, how many objects are created from this line?
Yeah, actually here you are creating one object.
Correct.
So we are using the reusability.
No. Sorry.
Do
You said right. So, okay. Where you are coming to this because base class constructor gets called first. Yes.
yes, that is correct.
So that doesn't mean base class object will get created. Okay.
Okay. Okay.
Be very right mindful on how right what exactly is happening on a heap. If
Mhm.
you just run this particular line, you will have exactly one object on your heap. If this is your heap, so with this line you will have exactly one object.
Yeah, that is correct. Okay.
Okay. Even though dog extends animal, right? So it's not that there are separate objects created for animal, no, and dog separately, no, that doesn't happen. So, okay, so now coming back to this, okay, now coming back to this, which one will take more memory? Now let's analyze, okay, members. Okay, so let's say I did the container shape. So for example, what I would have done is class dog, right? That's how we'll build the Haje, right? And mammal M1, okay? Or let's say, right, we keep it right in the constructor of the dog. I instantiate this also. Okay, let's say that's how it is. I do M1 equals to new mammal. Okay, I do this. Okay, so what I did, I created object here. I'm storing a reference variable. So this will also take additional memory apart from the object. Okay, so Haze will take more memory always than your each okay, keep this thing in mind.
Okay, yeah, sure, sir. Yeah.
Okay,
Thanks.
so
Yeah,
it's
I have
like
one question.
yeah, go ahead, Manjunath.
Yeah, the situation where you told has to be used, like if we have to use the mammal methods, then you said mostly will extend. So in has a relationship also we'll be able to access engine methods, right? I think engine dot that particular methods we can access.
Yes. Okay, so I said use is only if you want to inherit those behaviors. You also want to basically have those behaviors implicitly. That is one.
Okay,
Or
like in the sense what I told, like with dog reference itself, like reference only, we can use that
yes,
methods of the mammals. So
yes,
in
yes.
that here you have to instantiate use via engine you have to use.
Yes. That's the difference between EJ
Okay,
versus IJ. Okay,
okay, yeah, thank
cool.
you.
Okay, any more questions? Okay, what I concluded just now, right? You need to have, okay, Haze will take more memory because the assignment that you do here, you will create separate objects, okay? But in case of EJ, no separate objects gets created. Be very, very clear with this. If you have any doubt, we'll do the experiments, we'll show you. Okay, go ahead, Avinash.
Sure, sir. Yeah, sure. No. Yeah, thanks for the clarification.
Yeah, sure. Okay, go ahead. Okay, we'll just wrap this up, polymorphism and the encapsulation, and then we'll do some interesting questions, okay? That will help us clarify some of the other things. Now, we'll go to polymorphism. Polymorphism is nothing but, it's like you have the same name and you want to, right, have the different behaviors of it, okay? And there are two ways to achieve it. Either you do method overriding or you do method overloading. Okay. What do we mean by this? When we use either of them, we'll come to that. So method overloading, correct? Whenever I'm performing a particular functionality and I want to give, right? So for example, here in the calculator, I've added a function called add, and it just sums two integers and returns another integer. Now, for double, I had to create a new method. So what I did, I used the same add method because and ultimately they will also perform the addition. And always method names should be right what exactly the method is going to perform. Okay, so I mean, the other way to avoid this is like I could have used it something like add double, right? For convenience, but this is not the right, I would say, not the right as in not the standard thing. Okay, you can still use this, you can still, right, continue to use the same method name, and that's why Java provide it as method overloading. I'm just using the same method to perform different type of task. Okay, now overriding, when is that done, when is that needed? For example, I want to modify, I want to be called as parrot is a bird, that's for sure, but the way parrot sounds is different than other birds, correct? And that's why I need to override the method sound. Okay, and that's how we do it. Like this is an annotation, and how this annotation works and all, we will again come to this. This is a very interesting part, how you can write your custom annotations, and right, things work within that. We'll again come to that. But yeah, the main goal here is, if I want to change the behavior of the base class methods, I will go and override it. Or if I want to extend, let's say I want the parrot to do chirping also, and the way parrot speaks both, what will I do?
Override.
No, I overridden it, but I still want this method to be executed. What will I do? I will do super dot sound. Okay, first. Okay, I'll write that at this line. Fair enough. Any questions? I'll, I'll,
No.
I'll take it as no. Thank you. Okay, so what I'm trying to show here is the base class reference variable can have the object of, can hold the reference of the child class. That's how it is. Base class is bird, parrot is a child class, so it can hold address of this. Because parrot is a type of bird. That's why these references can be, right? This reference assignment can be done. Okay, now the method call that happens here, b dot sound, whether bird sound method will be called or parrot sound method will be called. Now, rule of thumb is whoever's object is created, right? Their method will be invoked during runtime. Okay, this is the rule of thumb. You need to always keep this in mind. Okay, whose method will run, whose sound method will get called. Imagine this line is not there. Okay, imagine this line is not there because I created the instance of parrot, so parrot's sound will come here and this line will get executed and print. No other line will get printed. This will not get printed. Fair enough. So we call it as dynamic polymorphism or runtime polymorphism because at the runtime it was decided that this method will run, not the base one. Okay. This is compile time because during compilation itself, so when in your main method, let's say you have a main method, something like this, and you will do is calculator, you will instantiate, right? New cal.
In the compile time polymorphism, that order of the method argument is matters, right?
It's like you need to change the signature. That's it. Not the order, just signature completely. So it's like these are two INT. You can have right three INTs also. That's also there. You can have one INT, one double, something like that. You can.
Yeah, like that I'm telling. Like
Yes.
if we can have combination of that, right?
Yes, yes, yes. You can have any combination of it. The only thing
Um,
is that your signature of the method that you are overloading that should differ from its original one. Okay.
okay, sir. Okay, and the same thing. The order of the argument of the method has to be strictly matched with the parent, right? For
Don't don't
overriding.
don't get confused.
Yeah. Okay.
Base class same method. Whatever is the signature that should come here in the case of overriding. If at all, imagine. Okay. You ask that. That's good. Okay. So keep asking questions, and I'll give you more clearer explanation of the examples. I'm just showing you. We are just talking about this guy, right? What is that? Okay. So let's say I'm adding a page. So I had a class bird. It has a method sound, something like this, and this has sys out, let's say something. Okay, chirping. Okay. Now this is the bird class. I'm just writing another class, let's say crow. Extends bird. Now what I'm doing is void sound, okay, string name. What it will do is sys out, okay, cow plus name. Okay, something like this. Okay, now tell me, is this an example of, now I did something like bird in the main method. Okay, bird b1 equals to new new crow. Okay, now I did first of all b1 dot sound, then sorry I did just a second. Yeah, let's say for now, right? Let's take this example. Now, first of all, tell me whether this sound is an example of overloading or overriding.
That's the overriding.
And the answer is no, this is not overriding.
Okay.
This is not overriding. Reason.
This is the example of overloading because the method name is same, but the argument is different.
Yes. So basically, Again, overloading also we call in context of the same class. Same class, you just add right, have separate methods, then we call it as overloading. Okay, this is not at all like the good. This is not the good practice. Okay, basically.
Here,
Uh-huh.
you are kind of a means extending the functionality of the sound method, right, into the
Correct.
subclass.
No, no. Again, so if I would have called it super dot something like sound, okay, then you can call this as extension of the whatever sound has done. Extension means whatever sound is doing, I will do that also. Plus, I will do additional. That's what is called as extension. Here,
Okay.
if somebody calls this method, you are not going to call your bird's sound method. Clear?
Okay, all right. Means it is a just the exclusive
Yeah,
implementation into the
yeah,
child.
yeah. This is like a new sound method that got written into the
Okay.
class. That's what.
Child method. Okay, okay.
Yes,
Child class, sorry.
yes.
Or we can say that this is the part of compile time polymorphism as well, because the compile time polymorphism extend the parent class features, and they, after extending the parent class features, so we can able to apply the
Compile time, I never said it does the extension. What I'm giving you is that it is doing the same, providing the same functionality on different set of parameters. This method is never going to call, it's not at all calling add method. So this is not extension. These two are two different methods intended for two different use cases. Okay.
okay.
Okay. So what I'm trying to give you is that in overriding, exact signature should match of this guy. Exact signature, whenever I talk about signature, three things, okay? Return type, name, and all the parameters that it has. The same should come here, then only it will be called as
Pa-
overriding. And
So
again, one
parameter
more.
and the same order as well, right? Of the
Yes, yes,
parameter.
same. Yes, yes, just like same. Or parameter matching always happens in the same order. If order changes, the parameters are different, okay?
Okay,
So,
yeah.
and another thing is that this annotation must be used. Override. Okay. Fair enough. In case
Yeah, sure,
of
sure.
in case of overriding, you have to have this. In case of overloading, you can have the same name, but yeah, different return type also is fine. Different set of right parameters are also fine. Okay, and so on. We'll just quickly wrap up the encapsulation part. Okay, so encapsulation is nothing but like it's wrapping both of them, right? Wrapping data and the variables, data and the code methods into a single unit. That's what we are calling it as encapsulation. What it gives you is that it gives you the control, okay? Restrict access, right? Restricting access to some of the objects components. That's what the job of encapsulation. Fair enough. Now, it gives you, right, accessor method. For example, because balance was made private, there are two methods to mutate the, one method to mutate the balance and one method to retrieve the balance, right? So this is the getter and then this is the, right, some sort of mutation that is happening. Okay. So encapsulation, nothing but you can just say wrapping of data and code into a single unit. The benefits, these are the two benefits that we have of encapsulations. Okay, data protection, controlled access using segregators, and that's it. Okay, now coming back. Okay, now you are being asked to design a library management system, right? Now this is the real life example. And how will you design? So that's how your class design will come. Very basic thing, how you understand things, right? First, you understand the system, what all will happen. You restrict their use functionalities, and then you start designing the class. Okay, I'm just giving object-oriented, right, programming example, and just to give you the practical experience of it. Okay. So this is the structure that I have put together. So I'm having a book. This must be an abstract class. And there are different type of books like fiction, non-fiction, comic, and so on. Then there is another entity called user, right? And then there is another entity called library. Now library has books. Library has this books. Library also will provide access of this books to the user. keep focusing on the terminology that I'm using. Okay. So library also provides you the access, access of the books to the users. Along with that, it will do the computation of the overdue, if you have any, while you go for submitting, it will go and do the computation of it. So that's overall, right, the very basic of this system. And we'll go through the example of this particular library system, how we can design, what are the different things we could do. That way we all will understand okay, how things are done. Okay, and before we proceed, we'll take a good 10 minutes of break, and then we'll resume. Is that okay for everyone?
Yeah, sure.
Sure. And meanwhile, anybody has any questions that we have gone through so far? I'm okay to take, or I'm also going to take another 10-minute break.
In the previous example,
Uh-huh.
like you were showing the code,
Okay.
what if we had done the b1.sound and we have given the parameter like parrot?
Yes, so that was an interesting question. So if I use b1.sound and parameter, so tell me whether the compilation will be successful or not with this.
The crow has sound and parameter, so it should have been
Crow.
compiled.
Okay. I'll come to that. Okay, so it's like, that's interesting. Let's say Shivam. I will take an example. Okay. Now there are two things I told you. Okay, and one thing which I told you is that runtime, what whose object is created, they will get, their method will get called. Somewhere I have written. Okay, I have written somewhere. I don't remember. But okay, but but during compile time, okay, compile time, this method will be searched. This method will be searched within this particular class. Okay, and we'll come to this. Okay, so after this break, we'll take this example and we'll show you how this happens. Okay. Okay, Shivam, fair enough.
Yeah,
Cool. Thank you. We'll regroup at 10, let's say 10:45. Let's say. Okay. Fair enough. Hey, I hope everybody's back. Give a thumbs up. Oh, sorry, I'll come back to the question. I hope recording is on. Okay. Okay, so just to clarify this, let's take this as an example. Compiler always look at the reference variables type. Fair enough. Compiler will always look at the reference variable type. What it means is that B1's reference variable is of type bird, and in bird class it will look for this sound method. This gets found. But if it try, compiler will try to see that okay, this sound class also should be present in the bird class, but which it won't find. It just has bird sound method which one with just empty signature, and that's the reason the compilation at this line will fail. As opposed to this, during runtime, the methods that is gonna be executed is from the instance, right? Is from the instance objects that is created with new. Okay, so that's why that's the difference actually. Okay, so compiler will always look for the type of the variable that is declared. It will try to find the method which it will find for this. For this it won't find, and that's why it will fail. Compilation will fail. Now the natural way of compilers checking is if the method sound is not found in this bird class, it will try to go the parent of the bird. If it's found there, it will try to consider and use. If it's not found there also, it will try to go it's their parent and so on. The chaining of this
So,
will enter.
sir,
Will,
the object is created for the subclass, right?
correct.
Here.
Correct. So object thing gets executed only during runtime. Compile time, compiler checks the type of the reference only. Okay. And then it will go
Oh,
its base and so on.
so type of the reference is for the parent class, right?
No, no, not for this also, right? For example, compiler will say that bird B1 is an instance of bird class. Bird class, it will try to look for a sound method with this name, signature, which it won't find.
Okay. Hmm.
Okay. Okay, I'll give you a nice example. I'll just stop sharing and then I'll give you that example. Okay, and before that, I'll also show you. hmm, I'll also show you the example of the smart library management system. Okay, just a second. So let me stop sharing from this. Stop sharing. Okay, I need to make this guy as presenter. This make host. Okay, so make host. Did I make the host? Make host. Yes. Actually.